Hello friends, I welcome you all to my channel. In this video, I will explain how to find limits of algebraic expressions, that is a rational function of algebraic expression using the method of factorization. So let's get started. Okay, so the objective is that we are given a function fx as a rational function of the form gx by hx, where gx and hx are algebraic expressions like terms containing x powers of x, rational powers of x, and hx is not equal to 0, and it's given that for some real value of a, ga is equals to 0 and ha is also equals to 0. So and we have to find the limiting value of fx at when x tends to a. So we have to find a limit gx by hx when x tends to a. So it becomes of the form 0 by 0 form, because at the point a, ga, gx and hx both are becoming 0. So the steps to solve this kind of problem is, since ga is 0, we must have x minus a as a factor of the expression gx. So we rewrite gx by taking out x minus a as a factor as below. We can rewrite gx as x minus a to the power p into g1 x. So we have taken we have essentially taken out x minus a uh, as a factor, and it may have uh, multiple x minus a as a factor. So we have assumed it has a power p for some p belongs to for some natural number p. And also we see that g1x is not, g1x at a is not equals to 0, because we have extracted all the we have extracted the factor x minus a from gx. Similarly, ha is 0, which implies that x minus a is a factor of hx. So we rewrite hx by taking out x minus a as a factor similarly below, and we rewrite hx equals x minus a to the power q for some natural number q into another expression h1x, where h1a is not equals to 0. Now from gx and hx, we cancel out the term, the factor x minus a, and then we find the limit by substituting the value of x as a in the expression g1x by h1x. Now, so the limit becomes limit x tends to a fx equals limit of gx by hx tending to a, which becomes, after rewriting gx and hx, it becomes limit of x minus a to the power p into g1x divided by x minus a to the power q into h1x. This further is simplified as x minus a to the power p minus q into g1x by h1x. Now, so this limit will depend on the power p minus q. So if p equals to q, so p minus q is 0, so there will be no factor of x minus a, and we will be left with g1x by h1x, and we can directly substitute the value of x as a. So we get g1a by h1a. So when p equals to q, the limit becomes g1a by h1a. Now, if p is greater than q, obviously we will still have a factor of x minus a in the denominator, and when we substitute x equals to a, it becomes, the entire limit becomes 0. So for p greater than q, we are having 0. But if p is less than q, we will have x minus a as a factor in the denominator, uh, and which will make the entire limiting value as 1 by in the form of 1 by 0, which is infinity. So in that case the limit will not exist. So let's try some problems. The first problem is limit x tending to 1 plus root over x square minus 1 plus root over x minus 1 divided by root over x square minus 1. Clearly we see that, so we are following the convention that the given function fx is gx by hx. So we clearly see that g1 plus is clearly 0, also h1 plus is also 0. So we have to factorize uh, both the numerator and the denominator, and we have to eliminate the factor which is the culprit that is causing this causing the limiting value to be in the form 0 by 0. So let's factorize the numerator and the denominator. So we have 1 plus root over x square minus 1. We can factorize these as x minus 1, x plus 1, and x minus 1. Similarly, the denominator we can write it as this. So we can take out, we see there is a we can take out root over x minus 1 as a factor from both numerator and the denominator, and since the limiting value is x is tending to 1 positive, uh, x minus 1 will not be equals to 0. So this becomes limit x tends to 1 positive root over x minus 1 multiplied by root over x plus 1 plus root over this becomes 1, and we have x plus 1 into x minus 1. We can write the denominator root over inside x minus 1 into x plus 1 as we can separate out the factors outside, bring the factors outside the root, because x minus 1 is positive because x is tending to 1 plus. So since x is tending to 1 positive, this implies x not equals to 1. This implies root over x minus 1 not equals to 0. Since root over x minus 1 is not equals to 0, so we can cancel out the factor. Now we can substitute the value of x in the remaining expression, and we get the limiting value as root over 1 plus 1 plus 1 divided by root over 1 plus 1. This becomes root 2 plus 1 divided by root 2 is the answer. Let's see the next problem. The next problem is limit x tending to 1 minus x to the power 1/3 minus 1/3 divided by 1 minus x to the power minus 2/3. So obviously we see that G1 is 0 and also Hx, H1 is also 0. So both the numerator and the denominator becomes 0 when x equals to 1. So we can factorize, bring out the, extract the factors from both the numerator and the denominator, try to cancel the common factor. So this becomes x tending to 1. If we simplify it, we get x to the power 1 by 3 minus 1 by x to the power 2 by 3 . This becomes x 1/3 minus 1 divided by x 2/3 minus 1, and we have the x 2/3 goes in the numerator and x 1/3 comes in the denominator, so it becomes what it becomes 1 by 3. Now this we can rewrite as, so this is x 2/3, we can write it as square of x to the power 1/3. So minus 1, we can rewrite this as 1/3 square minus square. This becomes x 1/3 minus 1. If we factorize the denominator using a square minus b square formula, we get x 1/3 minus 1, x 1/3 plus 1, and we have x to the power 1 by 3. So x is tending to 1 implies x not equals to 1 implies x minus 1 or 1 not equals to 0. So we can now cancel this factor and we are left with 1 . This is half. Okay, so let's see the next problem. The next problem is limit x tending to 2 x cube plus 3x square minus 9x plus 2 divided by x cube minus x plus minus 6. So we see G2 equals 2q plus 3 into 2 square minus, this becomes 8 plus 4 12 minus 18 plus 2. This is plus 2. Oh, this is minus 2, sorry, this is minus 2. So minus minus, this is 0. Also we see H2 is 2 cube minus 2 minus 6, that is 8 minus 2 minus 6 equals 0. So we will have x minus 2 as a factor from both gx and hx. So let's factorize gx and hx. We have x tending to 2. Now it's a power of cube. So the way I do factorize, or I will do the factorization is, first I will write x minus 2, and then it will have some terms, but the last final term to have minus 2, it must have plus 1. So similarly here, x minus 2 and the last term must be plus 3 because we have minus 6. So it must have plus 3. Now the first term of the numerator is x cube. So we have x here, we must have x square. So when we add x square, we are getting minus 2x square. But we have here 3 plus 3x square. So to adjust that, we need here plus 5x, because 5x square, we will have then 5x square, and here minus 2x square. So it will get adjusted to 3x square, and the rest will follow. You can see the 9x, we have minus 10x, and over here x. So it's fine. Similarly, for the denominator, we must have x square. This is x, okay. So x cube. So we are having minus 2x square. To adjust, we must have 2x, because there is no x square term. So 2x square, but then minus 3, we are getting minus 4x, and this 3x gets adjusted, and we are getting minus x. Yeah, so it's fine. Now since x is tending to 2, this implies x not equals to 2. This implies x minus 2 not equals to 0. So we can cancel this factor and then substitute the value of x as 2 in the remaining term, and we get the limiting value as this is equals 4, 10, 15, 15 by 4, 8, 11. 15 by 11 is the answer. That was question number 3. Let's do the next problem. Question number 4. We have limit x tending to root 3 x to the power 4 minus 9 divided by x square plus 4 root 3 x minus 15. So if we see g of root 3 is equals root 3 to the power 4 minus 9, this become 3 square minus 9 equals 0, and h of root 3 is root 3 square plus 4 root 3 into root 3 minus 15, this equals 9 plus 12. Is this square? 5, this root 3, 312, 3 minus 15, this will be 3, so equals 0. So x minus root 3 will be a factor of both g and h. Let's factorize and proceed further. X tending to root 3, over here we can write x square minus 3x square, x square minus, using a square minus b square formula, we can write this as x square minus 3 into x square plus 3. From here we have to, by middle term splitting, we can factorize this as x square plus 5 root 3x minus root 3x plus minus 15. This becomes limit x tending to root 3 x square minus 3 x square plus 3, and we do the factorization, we get x plus 5 root 3, x plus 5 root 3 multiplied by x minus root 3, x minus root 3. Okay, so now the culprit here in the denominator is x minus root 3. So we must also eliminate x minus root 3 from the numerator. So we can further simplify it as x minus root 3 x plus root 3 x square plus 3 divided by x plus 5 root 3 multiplied by x minus. Now since x tending to root 3 implies x not equals to root 3 implies x minus root 3 not equals to 0, we can cancel out x minus root 3 and then substitute the value of x as root 3 in the remaining term, and we get the limiting value as root 3 plus root 3 into root 3 square plus 3 divided by root 3 plus 5 root 3. This becomes 2 root 3 into 366 divided by 6 root 3. Okay, this becomes 2. 2 is the answer. Let's see the next problem. The next problem says limit x tending to 2 x cube minus 6x square plus 11x minus 6 divided by x square minus 6x plus 8. Okay, So at x equals to 2, we see G2 is becoming 8 minus 24 plus 22 minus 6. This equals uh, minus 30, yes, 0. And H2 also is becoming 4 minus 12 plus 8 equals 0. So x minus 2. So both numerator and denominator is becoming 0 at x equals to 2. So it must have a factor x minus 2. Let's factorize. So both will have x minus 2 as a factor, and over here we have minus 6, so it must have plus 3. And over here we have plus 8, it must have minus 4. Hmm. Hmm. Okay, so the denominator is simple, it's just a middle term splitting, and it will be x minus 4 will be x minus 4. So the numerator, we have x cube, so we must have x square. Now we get minus 2x square, but we have minus 6x square. So we must have another minus 4x square. So we will have minus 4x, so that it gets multiplied with x and we get minus 4x square. From here we get minus 2x square. Now the x term. The x term is, we have 3x and we have 8x, which becomes 11x. So it's fine. Now x tending to 2 implies x not equals to 2 implies x minus 2 not equals 0. So we can cancel out x minus 2 and we are left with the term where we can substitute the value of x as 2, limiting value of 2. Sorry, the tending value of x, that is 2. So we get 2 square minus 4 into 2 plus 3 divided by 2 minus 4. This is 4 minus 8 plus 3 minus 2. This is 7 minus minus 1 half. Okay. So that was all for the illustrative examples. I hope it gave you a little idea of how to solve limits of algebraic expression by the method of factorization, where the limiting function fx is the rational function of the form gx by hx, and at the limiting value both gx and hx is becomes 0. So we just factor out the we just extract the factor x minus a from both gx and ex and cancel that out. I mean, eliminate the culprit, which is the x minus a factor, and after they get the common factor gets cancelled out, we just substitute the value of a in gx and hx. As usual, I have prepared a daily practice problem sheet, whose link I will attach in the description below. Please try to solve them, and I will provide the solution of the DPP in the next 24 hours. So if you like this video, please support me by subscribing to my channel and like the video and share my channel and videos with your friends. And thanks for watching. Until the next video, take care and bye.